Today is 9.2, and it's probably one of the hardest sections of this chapter for a lot of students. If I were to pick out all of the hardest lessons out of the entire pre-algebra book, for some reason this one would rank right up there. Would probably be in that list of hard lessons. So what I would suggest is as we do a couple of things or do one slide, look at the problems in your book and complete those problems, then come back and look at the next slide and just complete your homework as you go through the video. Don't try to get it all in at once, or you can listen to the whole thing and then go back and listen again. But just be patient. It will come. And I promise you, once you learn how to do this, it will not be very hard to you. So we want to look at a few properties of square roots that's going to help us today. We're going to actually simplify square roots, and I'm going to show you what that is in a minute. But the properties that are going to help us today are these. When you have two numbers inside the radical sign that are multiplied together, you can actually split them up into separate radical signs like this. As long as a is greater than or equal to 0 and b is greater than or equal to 0. If it's not, you're going to have some imaginary numbers, and you don't want that. So in other words, if you have 9 times 7 underneath the radical, you can split it up like this. And if I split it up like this, I notice that 9 is a perfect square and has a square root of 3. So it can be written like this. Instead of this, we have this. And this is a simplified version of this. The quotient property of square roots is pretty much almost the same thing. If we have a fraction inside the radical, we can split the numerator and the denominator up into their own radicals. So we can do square root of a over square root of b, as long as a and b are greater than, as long as a is greater than or equal to 0, but b has to be greater than 0 because you can't divide by 0. It can't be equal to. Okay, so in other words, it kind of looks like this. If we have square root of 11 over 4, that's a square root of 11 over the square root of 4, and I know that 4 is a perfect square, so I can actually simplify this a little bit. This is a simplified version of this. Okay, so let's look at the first slide. We're going to simplify these. Now, some of the, I'm going to show you, if you have no clue what to do, I'm going to show you where to start and how to do it. And some of these are easy to do in your mind, but I'm going to show you how to do them if you don't know or you don't have a clue how to do it. So what we want to do is find a perfect square, the largest perfect square that goes into 180. You may know that. I know that. But in case you don't, this is what we're going to do. Do a little upside down division. So let me get a good color here. So we start with 180. Wow, that's a little thick. Certainly don't want to do that. Okay, here we go. Let's try this. There we go. 180. And we're going to divide by 2. Okay, so we're just basically prime factoring. Okay. 2, that goes to 90. Okay, we're going to go to 2 here. That's going to be 45. And we can't go 2 anymore. We're going to use 5. 5 goes in that 9 times. Okay, 3 goes into 9 3 times. And then 3 goes into that 1 time. So we go until we get the 1 at the bottom. Now what you're going to do is circle the pairs of numbers that you have. We have a pair of 2s, and I circled that terribly, but that's what we have. We have a pair of 3s. What you're going to do now is multiply the numbers you circled all together. So we have 4 times 9, which is 36. And then the leftover is basically the leftover. If we had more than a 5 there, we would multiply the leftover together. But we don't. So we're going to rewrite this as the square root of 36 times 5. Okay? Now, once we've done all that, that's the hard work. Now comes the easy work. So going back here, remember with the properties I just showed you, we can split those up. So it's the square root of 36 times the square root of 5. And this happens to be a perfect square. So to write this in a simplified form, you take the square root of that and you get 6, and you leave that the way it is, and it's just 6 square root of 5. And that's how you simplify a radical. Again, you're basically finding the largest perfect square that goes into this number, if there is one. Okay. So 63, you may know, but again, I'm going to show you how to do it if you don't know. We're going to do a little upside down division. Okay. Put the 63 here. Let's do 3. That goes into it 21 times. 3 again. That goes into it 7 times. Okay. 7's prime, so it's 7 and 1. Multiply the pairs together. We have 9 times 7. So if we do it like this, it's 9 times 7. Which, when you split it up, you get the square root of 9 times the square root of 7 I'm sorry, didn't mean to do that. Let's back up. Square root of 9 times the square root of 7. And I know the square root of 9 is 3. So now I can write it as 3 square root 7. And I need to make my square roots a little bit better to make it look like a square root. So 3 times the square root of 7. That's our final answer. Okay, and that is a simplified version of the square root of 63. Okay, here, 125, it's obvious what goes into that. We're going to do a little upside down division. Try to give myself a little room here. 5 goes into that 25 times. I'm sorry, let's do 125. 5 goes into that 25 times. 5 goes into 25 5 times, and we just have a bunch of 5s. Okay, now we're going to circle the pairs of numbers. Now we have 3 5s, but I can only circle a pair of them. Okay, so I've got 25 times 5. We're breaking that up into two things, 25 times 5. Okay, so it's the square root of 25 times the square root of 5. And that gives me, take the square root of the perfect square, which is 5. And then the rest, the leftover, is the trash, 5 times the square root of 5. And that is a simplified version of that. Let's look at 48. We're going to, let's do some upside down division here. We'll go down here. Okay, I like 2. 24, I like 2 again. 12, I like 2 again. 6, I like 2 again. 3, and we have to go with 3 here. So we got 2 pair of 2's, which we're going to multiply together, so we get 16. 16 times 3 is what we split this into. 16. I'm just going to go ahead and do it this way. Okay, so the square root of 16 times the square root of 3. 16 is a perfect square. That gives me 4 square root 3. And I'm done. Okay, let's look at 12. Without doing upside down division, this is pretty simple. The largest perfect square that goes into 12 is 4. And if you split it up, you get square root of 4 times the square root of 3. And I know the square root of 4 is 2, and 4 is a perfect square. So my final answer here is 2 times the square root of 3. Okay, and that is how you simplify radical expressions. You're looking for the largest perfect square that goes into this number because you want to break it into two numbers. And then you use upside down division if you don't know what that is. Let's look at the next slide. Here we're going to split it up. Okay, it's division, so it's basically looks like this. 100. We split it up like this into its own separate problems. And we know the square root of 100, we know the square root of 4. That's just 10 over 2. And we go ahead and simplify that, and that equals 5. So our answer here is 5. Looks really complicated, but a very simple answer. Okay, here we're going to split this up. Square root of 15 over the square root of 16. Well, we don't know square root of 15, and there's not a perfect square that goes into 15. We're going to leave that alone. So square root of 15 on top, and we know the square root of 16 is 4. Okay. Here, split this up. You get square root of 81 over the square root of 4. We happen to know both of those. Square root of 81 is 9, square root of 4 is 2, and when we divide that out, we get 4.5 for our final answer. Let me bring this one over here a little bit, make sure you can see it. So we have the square root of 7 over the square root of 25. Square root of 7 stays on top because we don't know that, but we do know the square root of 25 is 5. And voila, we're done. Now, if you get one of these that's really crazy big, you're just going to have to take it and do some upside down division to find out what to break it into. Okay, but for the most part, your division problems today should not be too terribly difficult. Next slide. Now, when you have variables, let's talk about the variables, talk about the square root of a variable and what that looks like. Okay, we'll get to these in a second. If I'm looking at variables, let's remember that when you multiply variables, you add exponents. So x3 times x3 is x6. Okay, or you can say x3 squared is x6. So x6 is a perfect square. What's the square root of x6? Well, it's x3 because you multiply x3 to itself and get x6. Okay, same way, let's look at x8. That's x4 times x4. x8 is a perfect square. Okay, the square root of x8 is x4. It's basically the square root is just half of the exponent. And you could do the same thing with x10. x5 times x5 is x10. So x10 is a perfect, I'm sorry, I did 10. x10 is a perfect square. The square root is x5. Now, since you're taking half of that to find out what the square root of that is, what's not a perfect square in variable when you're talking about variables? Well, it's when you have odd number exponents. So if I had x9, really you don't have a whole number exponent that's gonna work to give you a perfect square. So x9 is not a perfect square. Okay, but we can do something to it to simplify it a little bit, and that's what I'm going to show you here. So let's back up just a little bit and get rid of all that stuff. Okay, and let's look at this one. So we're going to basically we've got two separate problems here. We got the variable, and we got the number. So the number 24, you need a perfect square that goes into that. That's 4 times 6. Okay, and if you don't know, you can do upside down division. Just put 24 there and start dividing. You should have a pair of 2s, a 2 and a 3. So you have 4 times 6 times x squared. X squared is a perfect square because it's an even number exponent. Okay, so we're going to bring out the 4, take the square root of 4, that makes 2. This we're leaving in the radical. This we're bringing out because we're going to take the square root of it. The square root of x2, well, you take half of the exponent, it's x1. It's just x. Now what's left inside is only the 6. When we take the square root of these come out, okay? And that's what that is right there. Those came out as this. The trash stays in, that's what I call it. The 6 stays in. So it's 2x square root of 6 in its simplified form. Okay, 54. You know that 6 times 9 is 54. If you don't, you can do some upside down division. But we're going to break this up here. This is going to be the square root of 9 times 6 times x4. Now I have an even number exponent, so I know that's a perfect square. I don't have to do anything to it. So I'm going to bring this one out. Square root of 9 is 3. That stays in. It's trash. Okay. I'm bringing this one out by taking the square root of x4. And remember, I take half of the exponent when we're dealing with variables. x2. And the trash stays in. So square root of 6 is what I have left over there. So it's 3x squared because these two came out. And this one stayed inside, square root of 6. Okay, next one. Now this is all variable. These are all variables, and it's going to be very simple. They're all even exponents. So to take the square root, again, of variables with exponent, you take half. So the square root of x4 is x2. The square root of y2 is y1. The square root of z8 is z4. They all came out of the radical sign. There's nothing left in there, so we don't have a radical sign we have to write. Okay, now this one, I'll tell you what, let's come back to this one. I want to talk about it, and then let's do this one first. So I'll bring this down here. We're going to break it up. Square root of 32 over the square root of x squared. Okay, let's think of 32. That's 16 times 2. 16 is a perfect square. So what I'm going to do is, again, utilize my space. I'm going this way. It's 16 times 2. And on the bottom we have the square root of x squared. Now we can finalize this problem. Here we're going to take the square root of 16, which is 4. And on the bottom, square root of x2 is x1. Now the trash is here, square root of 2. We can't take the square root of 2, so we're going to leave it in there. So I have 4 square root of 2 on top, and I have x on the bottom. Okay, and that's its simplified form. Let's look at this one. Okay, and this is how you have to work problems when you have an odd number exponent. They all work the same. Okay, they all work exactly the same. We're going to have to do something with this. So I'm going to leave x the way it is because it's a perfect square. But I'm going to split y up into a perfect square and something that's not a perfect square. And what you do is you basically take 1 out of that, so you do y1, and then the leftover, which would be y2, because when you multiply these, you get y3. Now, when you do that, notice this is the same as this. It's just in a different form. When I do that, I can just go ahead and deal with these two things. These come out of the radical. So the square root of x squared is x. The square root of y squared is y. And the trash, the leftover, is simply y. Just like that. No problems there. Okay, so again, let's say we have, let's do some bigger numbers. Let's say we had x7, y9. Very simple. We're going to do the exact same thing we just did. So we're going to split those up. The 7, I'm taking 1 out of that, and I'm going to have the leftover, which is x6. Okay, take 1 out of this one, and the leftover is y8. Now, the trash is going to be here and here. That stays inside. These two come outside. So the square root of x6 is x3. The square root of y8 is y4. And then the trash is inside. That is x1, y1. And when you're splitting up variables, when you have an odd number exponent, always do it like this. Take 1 out of it and have the leftover. Take 1 out of it and have the leftover. And that's how you do variables. They're very easy to do once you learn how to do them. Okay, and now those 3 slides pretty much sum up what we're doing with simplifying variable expressions, radicals, and variable expressions. Basically, once you get this down, it's going to be very simple. It'll be very simple for you. It's just new, and things that are new sometimes overwhelm, but don't get overwhelmed. Everybody's able to do this. You'll be able to do it just fine.